Another nice thing that you can do is once you've defined a page and a collection of elements in it, for example here the home page with just these 4 elements, in your test script you can access all of the elements as an array or a hash if you want. So it's easy to just build a loop which just iterates through each element and performs some command on it. In this case we're just doing an assert present. If we wanted to, we could do something a little bit more, we could do something different, like get its text or find out some of its attributes or do different assertions on it, make sure it's visible and everything. I do want to point out one potential limitation in this sort of approach. The way that things are set up right now is that a lot of our pages are pretty big and complex, and depending on the state of the type of user and just kind of the state, whether you're logged in or logged out, or whether you have certain credits on your account or whatever it may be, how many connections you have, some elements might not always be present on the page. So if we have a page defined with all of the elements which could potentially be there, this technique doesn't really help us much because some of those elements might actually not be there. Another, I guess, somewhat of a more advanced problem that we encounter frequently that we can solve with the page object pattern is needing to build contextual locators. So looking at the markup here, we just have a list with list items. Each list item has a couple child elements. And if we want to iterate through this and pick up like each of the H1s out of there, we essentially have to use XPaths with indices. So you can see in the code snippet at the bottom, it's kind of rough, but I mean it's fairly simple, fairly straightforward. I'm just starting out by building a string which has an index of 1, which is the initial value of the index variable. And then as long as that element is present, I'll increment the index and rebuild the locator and then check again. So using this sort of technique, I can essentially loop through a collection of items until we run out of them, until there's no more left to loop through. So this works. However, it still has the flaw of having essentially a hard-coded element locator in here. For example, if the ID of that messages list changes to something else, now we have to edit our test scripts rather than editing one of our page files. So a way that we can abuse the page class to be able to generate these things without having to inject actual hard-coded elements into our test scripts is by using the Ruby proc, which is essentially a small, like a block of code that can be passed around and executed with various arguments. So when we're defining an element here, subject by index, rather than just giving a string for a locator, we give a proc with a variable kind of interpolated into the string, so that later on we don't have to decide what that placeholder is now. We can inject that later. So you can see in the sample code below, I'm going through essentially the same kind of loop I did before, but instead of needing to build the XPath manually, I can just pass in an index, which gets substituted into the locator, the XPath. So a bit about the supporting infrastructure that helps all of this kind of stay together and provide us good test results on time and everything. We have a lot of test helper and utility classes. This is kind of one of the primary ways that I think our approach differs from a lot of the page object approaches that I've seen in the past, where functions and methods will actually be defined on the page. So for example, you might commonly see like a search page dot do search something, and then that'll return some sort of objects. Instead of doing that, we basically limit our page classes to just providing access to the elements on those pages themselves. So you use pages and elements when you need granular control over what you're doing with the test. But conversely, we have these kind of domain-based helper and utility classes, which we use to perform common functions, setup functions, things like login. So for example, we have test helper classes for like authentication, registration, connections, checking email, sending messages, all that sort of stuff. We also have a multi-threaded test runner that we built in-house. It's pretty cool. It allows us to be able to run a lot of tests at the same time, which really cuts down our execution time. So we have a lot of tests, and Selenium is really slow. So, well, not necessarily Selenium, but testing through the browser is really slow. So we want to be able to run several at once. And also, we have specialized environment-specific data classes that we used. I mentioned those in the first slide, or the first example of the test unit test case. So we can instantiate a data class just depending on whatever environment we want to test, and it'll carry with it some specifics of that environment about the URLs that we need to hit and the different users and their credentials that live in that system. We also extended the test unit test case class to carry some extra attributes so that we can define like test script priority and grouping, tagging, whether or not it requires isolation, some things like that. So that way we can build kind of custom-based test runs. We can say like run all of the medium to high priority test scripts from the core group or whatever, and kind of get like on-the-fly test suites. We're also one of our big challenges with our testing is actually dealing with usually user-based test data. So we always need to create a lot of users and get them connected in certain ways and have them send each other messages and updates and stuff. And it's very expensive to do that in the setup cycle of every one of our tests because we're going through the UI, we're going through Selenium, so we have to get the stuff from the server and then render it, and it just takes a long time. And also it's somewhat fragile because now if a piece of the application is broke, which our setup depends on, then we can't even run our tests. So we're kind of in the process of building and integrating more of like a headless approach to generating and setting up our test data. So that'll be cool. A couple statistics about since we've started this thing. We adopted this model around 6 months ago. We've created a lot of test cases, probably 1,000 by now. They're growing really fast. We're hiring more people to write more and more test cases, and it's really ramping up at a pretty fast pace. There's a lot of activity, not just creating new tests, but then fixing page classes, and also I have to admit, there's locator abstraction is not the end-all be-all of getting rid of your test maintenance headaches. I mean, still, if the UI changes around drastically, there's still flows that break and stuff like that, which need to be accounted for. But so we do have an average of like 28 test-related commits to our repository. The average number of elements per page is 18, which when I first saw that, I thought it sounded kind of low. Then I thought about it, and there's a lot of pages which we don't necessarily care too much about testing, but we need them as part of a test, or we just want to check some key things about them. So 18 is really, I guess, it's a pretty good number for elements that we interact with. Over 200 defined pages. And that's about all I have. I want to just give an acknowledgement to some people on my team at LinkedIn who helped in one way or another to contribute to this. So I don't think any of them are present, but thanks anyway. And also, of course, thanks to Sauce Labs and Mozilla for hosting and organizing this meetup. I think it's a real service to the community. So, thank you.